Hello and welcome to the second video in our Year 9 coordinate geometry series. In our first video, we covered the distance formula and the midpoint formula, and today we'll be looking at the gradient, or otherwise known as slope. So what are lines, first of all? I think it's important to have a definition of what lines are in general. So in geometry, a line is a straight one-dimensional figure that does not have a thickness and it extends endlessly in both directions. So you can see in this diagram here, I've drawn these arrows to show how it goes forever in both directions. So obviously on the coordinate plane, they're drawn simply as straight lines that extend outwards. Pretty straightforward stuff. So let's introduce the idea of slope, otherwise known as gradient. If you can look at the two lines below, you can see there's a line on the left and a line on the right. You can see that the one on the left looks distinctly steeper than the one on the right. And that is because you can see for the same amount of horizontal distance, this one goes up by a much larger amount than over here. If you were to go horizontally by about the same distance, you can see it only goes up by this small amount compared to the line on the left. So what we can say is we can say that the line on the right has a less steep or a smaller gradient or slope than the line on the left. So let's actually try and formalize this and talk about what that actually means. So the gradient of a line measures its slope. On the number plane, the gradient is a measure of the amount of change in y. So remember, y was our vertical axis per unit change in x, which was our horizontal axis. So basically, we're saying how far does it travel up for going across? We give the gradient symbol the letter m, so small m. That is very different to capital M, which is what we used for midpoint formula. And so we say that gradient is defined as rise over run. Now, obviously, that isn't our formal definition. Mathematically, we can actually calculate the gradient of a line between 2 points, and we call these 2 points x1, y1, x2, y2. The gradient is known as m equals y2 minus y1 over x2 minus x1. Now, quickly, before we move on to the next slide, I'm going to show you a quick proof of how we're going to, I guess, how this definition even came about. So if I just have a coordinate plane right here, and I just make 2 points, right? We'll call this point 1, and we'll call this point 2. So we'll call point 1, actually, I'll call this point 1. We'll call point 1 x1, y1, and we'll call point 2 x2, y2. And remember, all x2 and y2, all of them, they're basically just the x coordinate of the second point. This is the y coordinate of our second point. And similarly, this is the x coordinate for our first point and y coordinate for our first point. So if we look at the informal definition, gradient is defined as the rise over run, right? So how do we calculate the rise? Well, it's probably a good idea to actually join these guys together. So let's just do that. I'll choose a different color here. Now, if we are to join these two lines, these 2 points together using our line, then you can see we can actually further split this up into a rise. So a rise would be like this. So this would be our rise. And our run, well, our run would be like this, right? So rise over run. So what is our rise? Well, you can see that this point here correlates to y2. This point here correlates to y1. So the difference, this orange line, has a distance of y2 minus y1, okay? And similarly, if we were to look at the horizontal, right? If we look at our run, you can see this point here is x1 because that coordinate is, x2 because that coordinate is x2. And this coordinate here would be x1. So we can see that this horizontal distance, equivalent to this green line at the bottom, that's going to be x2 minus x1, okay? So you might be like, wait, but what if y2 and y1 was on the other side? Like, what if this point was over here? Does that still work? And the short answer is yes, it still works. And that's just because when you flip the points over, you're also going to be flipping this over. But basically, as long as you do 1 point minus the other, you'll be all good with rise over run. So let's put this into an example. A line passes through the points 2, 3, and -1, -4. Part A, let's draw the line. So first we have a coordinate plane here. Let's actually just write down all the numbers. So we've got 0, 1, 2, 3, 4, -1, -2, -3, -4. I'm just going to plot the points that I actually need now. So this is going to be 2, and I would also need -1. So draw the line. So we've got 0.23. Let me plot that. 2 here, 3 here. So that's going to be 0.1. And then -1, -4. So that's -1. That's -4. That is the second point. So now I'm going to join them up using my black color. It's not amazing, but bear with me. There we go. So I've drawn the arrows there to show that it goes on forever. And then part B, find the gradient of the line. So we can do this either of two ways, and I'm going to show you both, right? So first, let's just look at it manually. You can see that the rise, we're going from -4 to a coordinate of 3. So hopefully you can see that that is a rise of 7 units, okay? Because if you want to use your number line, you can see if we start from -4 and we want to end up at 3, we would have had to jump 7 times to get there. And for our run, you can see our run, well, we start off at -1 and we're hopping over to 2. So that's 1, 2, 3 units. So a run of 3 units, okay? Make sure you understand that when we're going to the right, it's positive, and when we're going up, it's going to be positive, okay? So if I was to say from 2 to -1, well, that would be going left. So that would be -3 units. But for now, we've got rise of 7 units, run of 3 units. So if you plug it into the rise over run, that's going to give us 7 over 3. But let's just ignore this because this is really quite tedious, especially with like harder questions with weird coordinates. How do we use our formula? Well, we use the formula m, small m means gradient, is y2 minus y1 over x2 minus x1. Now, it doesn't matter which one is x2 and which one's y1 and all that, as long as you're consistent with it, which means if you choose this one to be x1, then this has to be y1. If you choose this to be x2, then this has to be y2. If you chose this to be x2, then this would have to be y2. So hopefully that makes sense. So now I've just set them like that. So that means y2 minus y1. So that would be -4 minus 3 over x2 minus x1. So that would be -1 minus 2. That gives me -7 over -3. And we know that -7 over -3 is the same as 7 over 3. So you can see we can still get the gradient of the line as long as we're consistent with how we're naming our points. So with this next example, ABCD is a parallelogram. The coordinates of A, B, and C are -1, 4, 4, 6, and 2, 7 respectively. Find the coordinates of D. So pause the video here and then have a go at doing this question, and then we'll go through the solution together. Okay, so hopefully you've had a chance to have a go at this question, and now we're going to go through the solution. So the first step for this kind of question is always draw a coordinate axis, a coordinate plane, and then plot the points that we do have. So we know we have -1, 4. So that will be point A. So I'll label that A. Then we have 4, 6. So 4 would be about here. 6 would be about, let's say, here. So that would be 4, 6. Label that B. Then we've got 2, 7. So 2, 7 would be around there. And 7's about there. So right there. That would be C. Now, how do we make this a parallelogram? Well, the answer to that is that there's actually 3 answers, okay? So we could have a answer of D here. We could have, so that would be this parallelogram. I'll just draw that out in green so you can see. So I'll call that D1. D2, that's where if we have the point over here somewhere, so if we have D2 over there, you can see that this would spell out a parallelogram as well. And finally, we can have D3. And the way we're going to get that is going to be if we have this over here. And you can see that because these two sides are going to be parallel, and so are these two sides. So the question is, how do we actually figure out what D1, D2, and D3 are? Basically, we're going to use a bit of common sense here and realize what these points are. You can see that A to D1 would have to be the same as C to B, right? So what is from C to B? Well, C to B, we're basically going down by one Y unit, so down by one Y unit, and across by two X units. So that's what we're going to do to point A. So to get D1, we're going to get point A, which was -1, 4, and we're going to plus, you can see plus 2 Y units, two X units, and -1 Y units because we're going down. And so that's going to equal 1 and 3. Now, doing the same thing for D2, you can see D2, this is over here. You can see that AC has to equal BD2, right? So we just need to figure out what AC is. A to C, you can see, is going to be, well, we're going from -1, 4 to 2, 7. So we're going across by 3. So X value of 3, we're going adding 3. And then we're also adding 3 on the Y values. So that means all we need to do is do point B, which is 4, 6. And then we're going to be adding point B to D2. So that's going to be our 3, 3. And that is going to equal 7, 9. And finally, to figure out D3, well, you can see D3 is over here. So we could use B to C and add that onto A. Okay, so B to C, you can see this is B, this is C. So B to C, we had to -2, and we had to +1 on our Y coordinate. And obviously we're starting from A. So A is -1, 4. So if we do the math here, we're going to get -3, 5. And always reality check your answer. Does this look about -3, 5? Well, it definitely looks like -3 here. Does it look like 5? Yeah, it does. So that's how you do these kind of questions. The formal name for this is called vectors. But for now, as long as you can understand that a parallelogram is going to be obviously having two opposite equal sides, two pairs of them, then we can use that logic to find the 3 answers. Let's have a go at another example. Determine which graphs have gradients, part A greater than 0, less than 0, equal to 0, and undefined. So remember, greater than 0 means it's pointing upwards as we're going from left to right, okay? Less than 0 means we're pointing downwards as we go left to right. Equal to 0 would be a flat line. So we can already say that this one here is going to be equal to 0. Undefined, that means, so let's just do a quick little sketch here. So we agree that lines pointing this way are negative, less negative, flat, so 0, positive, more positive. What if we have a vertical line? That means we have a rise, but we have no run. The run would be 0. Now, if you divide something by 0, hopefully you know that the answer is undefined. So you could technically think of it as the gradient is infinity, but in reality, the gradient is undefined. And so that's why this one here, which is a vertical line, has a undefined gradient. Obviously, this one would be greater than 0 because you can see it's going up as we look from left to right. And this one here would be less than 0 because it's going down as we look from left to right. So hopefully that makes sense. So that brings us to the end of this video on slopes and gradients. Hopefully that makes sense. In our next video, we'll be covering how to find the equation of a line. So hopefully catch you there.